So good day everyone. So this is my masterclass number 4. So in this masterclass, we're going to discuss the length of the curve, um, the surface area, and the centroids. So first we have the length of the curve. So in principle of the length of the curve, we have here first plotting. So this is your x and y axis. So this is your x axis and this is your y axis. So next we'll create curve. So like that. And then we will label this curve as your L. This is your L. And then um, we'll call this your point A. And then we'll call the end of your curve is your point B. So next, for solving the length of the curve, we will use our strip. So let us put here a strip. So this is your strip. And we'll label that as your DL, the derivative of your L, right? So next, um, this from that point downward is your y, and the point here is called your x. So if we're going to make another dimension from here to here, it's called your dy. That so this is your dy, and then from here to here is called your dx. Okay. So next, we're going to solve for the differential length. So in order to solve for the differential length, we will use our Pythagorean theorem. So first, we're gonna take this out. So this is your strip, label as your dl, and then this is your dy, right? And this is your dx. Okay. So we will apply now our Pythagorean theorem. So in Pythagorean theorem, we have here your hypotenuse, your opposite, and your adjacent. Uh, D. I mean ADJ gali. This is your adjacent. So according to the theorem, um, we will square the hypotenuse, which is our DL, and then this will be the hypotenuse. The square of your hypotenuse will be equal to the square of the sum of the two legs. So first we have our adjacent. So this is your dx squared, and then plus your opposite, which is your dy squared. Okay. So next, we're going to solve for our dx. So if we divide this by dx squared, um, our result will be, so this is will cancel out. So dl over dx, oh wait. So this will be become dl over dx squared. So this is 1 equals to 1. Wait, this is squared is equals to 1. Then your dy over dx squared. So, as we all know, dy or dx, this will be equal to y prime, right? So, our formula here are, so simplifying, we have dl, wait, we have dl over dx squared. So, this is squared is equals to 1 plus your y prime squared. Okay, so we'll cancel out, we will root both sides. So in order to cancel out the square here, so this will become dl over dx is equal to the square root of 1 plus y prime squared. So next, we'll multiply both sides in order to, we'll multiply both sides by dx in order to cancel this out. So your dl is now equal to the square root of 1 plus y prime squared, and then multiply it by your dx. So next, we will integrate both sides. So we'll put that in here. So integrating both sides, we have L is equals to integration of the square root 1 plus y prime squared dx. Okay, so the limits is from A to B. Alright, so this is now your formula. Solving for the length of the curve respect to dx. Okay, so next, if we're going to solve for dy, we have here, let us put here, so dl squared is equals to dx squared plus dy squared. Okay, and then multiply it by dy squared. This will cancel out. Next, we have dl over dy squared is equals to dx squared, dx over dy gali, squared plus 1. So in here we have y prime, so in here we will have x prime. Okay, so this is x prime squared, right? So next, this will become your dl, simplifying the square root of x prime squared plus 1 dy. Okay, so integrating, we have your length is um, equals to the integral of 1 plus x prime squared square root gali, and then your dy. So we have our limits. So I mean, we don't have our limits, so let us put here. So this is your c, okay, and then the line here from the point here to the y-axis is called your d. So we have now your limits. So this is from c to d. So this is now your formula for solving the curve with respect to dy. This is dy gali. So for example number 1, find the length of the curve of y is equals to square root of x from x equals to 0 to x equals to 5. So for our solution, we'll plot first. So this is your plotting. So this is your x-axis and this is your y-axis, and this point intersection is 0. So the curve, you have y is equals to square root of x, which is like this. So this is your y is equals to square root of x, right? So from that, we'll first make a strip. So let us say you have a strip here. So this is your strip. Then we label that as DL, right? So wait, from 0 to 5. So let's say this is your 5, 0.5. Next, we will find, we will take the dimension. So from this point to this point, this is your y. Then from this point to this point, this is your x. Okay. So from this point to this point, this is your dy, and then your dx is from this point. So this is your dx. So um, uh, so we'll put that in here. Next, this is your strip. This is your, let me make this bigger. So this is your strip. This is your dl, label as your dl. This is your dy, and then this is your dx. Okay. So next, we'll solve using the formula. So since this is respected to x, so to dx gali, so we'll solve for we will use the formula in terms of dx. So this will be equal to the length is equals to the integral of 0 to 5. So that is your point. Next is square root of 1 plus your y prime squared. Then times it to the x. So from here, we will solve for the y prime. So the derivative of, so this is your y. So the derivative of the square root of x is simply 1 half square root of x. 1 over 2 square root of x. So this is now your y prime. Next, we will apply your y prime in this equation. So this will become 0 to 5, 1 plus your y prime, which is 1 over 2 square root of x squared. Okay, and then your dx. So solving for this, using calculator, so the answer in this is 5. According to the calculator, this is 5.64 units. Okay. So this is for your example number 2. So find the length of the curve of y is equals to 3 sine x from x equals to 0 to x equals to 3 pi over 2. So first, we will manipulate this. We will understand first the problem. So this is 3y, 3 sine x. So as you will know that omega here is equal to the angular value of your sine x. So the angular value of sine x here is 1. So omega is equals to 1. So omega, the formula for omega is equals to 2 pi over t, right? So in order to solve for the t here is your period. So t is equals, 1 period is equals to 2 pi. 2 pi, yes, 2 pi. So now we can draft a graph. So this is your solution. First, graph your y. So this is your x and this is your y axis. This is your 0. So next, this is your curve. This is the curve of your y, which is 3 sine. Oh wait, y is equal to 3 sine x. 3 sine x. Okay. So this is called your period. This is one period of 3 sine of x. So we have here 2 pi. Okay, because one period is equals to 2 pi, right? So this is your 2 pi here. Let's label that from here, from your y-axis to the point here is called your t, which is 1 period is equals to 2 pi. Okay. So next, if we divide it by 2, this will become your pi. Okay, so divide it by half. This is your pi over 2. Pi over 2. And then when we divide this by half, this will become 3 pi over 2. So now we have now our limits, 3 pi over 2. So next, um, we'll solve for the ano ulit. But first, since 3 here is the amplitude, so we have here positive 3, and then under here is your negative 3. Okay, so next, solving for the length of the curve, we'll put here a strip. Wait, we'll put here a strip. So this is your strip labeled as DL, and then um, this is your dx, and then this is your dy. Okay, so we'll put that here, so make it bigger. So this is your dl, this is your dy, and this is your dx. So solving for your length, so the formula here is equals to, since we have now our limits, 0 to 3 pi over 2, and then this will become, 1 plus your y prime squared, then your dx. Okay, next we'll solve for the y prime. So we have here y is equals to 3 sine of x, and then the derivative of that is 3. The derivative of sine x is 3 cosine x. Okay, so we have here our y prime. So this is 0 to 3 pi over 2, and then square root of 1 plus cosine x squared, and then times your dx. Okay, so solving that in your calculator. So for our final answer, we have 14.88, I mean 14.89. So this is 89 units. So this is your final answer for example number 2. So for our next topic, we have the surface area. So the principle of the surface area. So first, we'll plot. So this is your axes. So this is your x-axis, and then this is your y-axis. So next, we'll draw curve. So this is your curve right here. So this is called your y is equals to the function of x. Right, next. Since, wait. So this is your point A, and then this is your, let's say this is your point B. Okay. So next, um, we'll create a strip. Okay. So creating the strip, we have here strip. So label that is your, oh wait, we create first point. This is the point. So label as your x and y. So next, we're going to create a strip. So this is your strip from this point to this point. This is your strip. Okay. So the length from your strip to your y-axis is called your x. And the length from your strip downwards is called your y. Okay, this is your y. So next, um, the thickness of your strip is called your dx. Put here your dx. The thickness is your dx. So this is your the length here. Strip is your dy. So the name of the strip is called your L. I mean the length of your what do you call this? The length uh of the curve is DL. Is L gali. Okay. Okay, so this is L. So since it is rotated, call this rotation, your area of rotation to the x-axis, um, this will become a um, shell like that, um, like this, and then your strip. So okay, so this is what it looks like when rotated to your x-axis. So we will put that in here. So for this is now your you call this your strip. Oh wait, so this is your strip and your area of rotation. Okay, axis of rotation gali. My bad, sorry. So we will label the thickness is your DL, and then from this point to this point is your Y. So if we cut it in half, we have what you call it, the rectangular line. Yeah, record ko pa yan na to. Sino wifi? Ikaw nantawa na to ya sa may box kang ano, may password to ya. Pero why? So if we're going to cut this, we have a rectangular, vertical rectangular box thing right here. So we'll call this your DL, and then the length here is your 2 pi y. Okay, so the area here is your DSA or the differential surface area. Okay, so the differential surface area is equals to 2 pi and then your y times your y and then your DL. So next, um, we will simplify this. So this will become 2 pi y square root of 1 plus y prime squared dx. Okay, so next, um, uh, we'll make it x prime. So this will become 2, then 1 plus x prime squared times your dx. So either way, our surface area is equals to the integral, if we integrate this, the integral of from point A to point B, um, 2 pi y, then square root of 1 plus y prime squared dx. So now we have your formula for the surface area. So for example number 1, we have find the surface area of the line of a line x plus 4 is x plus y is equals to 4 from x equals to 0 to x equals to 4 rotated about the x-axis. So first we're gonna plot. We're going to plot kila. So this is your axis. So this is your y-axis, and then this is your x-axis. This is your origin. So next, the line here x plus 4. So this is your point 4, and then your 4 point here is 4 also. So the line here is like this, right? So the line here is equals to the line here is equals to y um, y plus x is equals to 4 or the same. It's also the same. So next, we will create a strip here. So this is your strip. This is the point, the starting point of your strip. This is labeled as x and y. Okay. So the strip is called your DL, right? And then from here, the point here to here is your x, and then the height is your y. Okay. So next, since wait lang, it is rotated or about. Okay, it is rotated about the x-axis. We're going to rotate it. So we have to rotate. So this will become like that. Okay. So this is now your rotated version. So if we going to put it in here, we have um, like this, that. Then this is your AOR, or axis of rotation. Okay, so the point here is your Y, and here the thickness is your DL. I mean your strip is your DL. So this is your DSA, and then if we're gonna cut it in half, we have a rectangular vertical shape here. So this is your DL, this is to your 2 pi Y, and then your DSA will be equals to um, from 0 to 4, wait, from 0 to 4 to pi Y um, DL is equals to 2 pi Y square root of 1 plus your Y prime squared dx, right? Kasi ang your DL, the formula of your DL is this. I mean, dala pang dy, right? This is your formula for your DL. So if we simplify this, we have um, uh, I mean, if we ano ulit, if we simplify that, we have integral from 0 to 4 to pi. So y here, so your y is equals to so we're going to ano this. So we're going to simplify this. So this will become I mean this will become y is equals to 4 minus x. Okay. So this is now your y. So we copy this 4 minus x, and then copy 1 plus, since prime here, your y prime derivative of y is equals to negative 1. Okay, so this become negative 1 squared times your dx. So solving for the integral, so solving for the integral, your SA will become 71.08, and the unit of measure is square units. All right. So this is your answer for example number 1. So on this topic we have centroids. So the principle, okay, wait. So in this topic we have centroids. So the principle of centroids is first plotting. So this is your x-axis, and this is your y-axis, and this is your origin. So for example, we have here your curve, namely your y is equals to the function of x, and then we have your points. So this is, for example, this is your point A, and then this is your point B. Okay. So next, um, we'll make a strip here. So this is your strip. Since this is centroid, we'll make it in the center. So this is your strip. So from your strip to your y-axis is called your x. Okay. So the thickness is your dx. Okay. So next, or the height of your strip, it's called your y. This is your y. So next, in centroids, um, we'll take so next gala, we'll take the centroid of this strip right here. So since this is centroid, we'll put it our centroid in the middle. So this is your centroid. So we will label that. So from your centroid to your x-axis, this is called your YC. YC or your YC because it is the centroid value. So next, from your centroid to your y-axis. So this is called your XC. Okay. So does it does that it does that uh so next, we'll put your centroid, I mean your strip in here. So this is your strip right there. Okay, so we will label this as your dx, and then the height of your strip, which is your y, and then half of that is your yc. Yc. Okay, so solving for that, we have your d8 is equals to y dx. So here, we will apply your yc. So yc is equals to your um, a1 times your yc, and then the total area. So this is the total area. So this will become the integral from point A to B. Then your y over 2 here, because yc here is your yc here is one half of your y, right? So this is your yc, which is one half, okay, times your y. So this will become y over 2. So next, this will be multiplied by y and your dx. Okay. So next, wait, before that, this will become um, integral from a to b, and then your y dx. So this is the formula for your yc, and for your yx, uh, xc galit, we have your a1 again times your xc, and then your total area, right? That. So this will become the integral of from a to b xy dx. Right. So simplifying further. Wait. And then you have the integral of this will be divided to the integral of from a to b times your y dx. So this is your formula for xc. So for example number one, we have the centroid of a quarter circle. So plotting for the quarter circle, we have your y-axis, your x-axis, and your origin. So quarter of circle means this is your curve or line, your curve. So this will be equal to x squared plus y squared is equals to 4. Okay, so the line here like that. So from 2, this is 2. So next, we will solve. Uh, we will put our strip right here. So this is our strip like that. Okay, so again, the length, the height is your y, and then the length is your x. Okay, so then the your the thickness is your dx. Okay, so this is your centroid, and the height from your centroid to your x-axis is your yc, and then um, from your centroid to your x-axis is your xc. Okay. So next, we'll put this vertical strip here. So now this is your vertical strip. So again, the height of your vertical strip is your y, and then half of that is your um, yc, or your y over 2, right? So the thickness is your dx. Okay, so solving um, solving for yc, we have a area times your yc, and then your total area. Next, this will become integral from 0 to 2, and then y squared, y squared, because that is your area. So y squared dx times your 1 half over integral from 0 to 2, 1 half, your y dx. Okay, next, um, we have here integral from 0 to 2, 1 half y prime, um, integral y prime, I mean your y squared anay gali, y squared, alright, y squared dx over the integral from 0 to 2 y dx. So next, integrating, we'll put 1 half outside the integral. So this is from 0 to 4, 4 minus x squared. Why 4 minus x squared? Because it's become pi over 4, 2 squared. So next, simplifying this, we have 0.85 units. Okay, so that is your final answer for example number 1.